Hi everyone, let's talk about casework and complementary counting. The idea behind casework is that we have something like a set A and it's equal to a set A1 union set A2 union all the way through to AN for some positive integer n, usually greater than or equal to 2. And what we have is that these sets are pairwise disjoint. So it's really a disjoint union. We can write it like A1 disjoint union, A2 disjoint union, all the way through to disjoint union AN. And what we're looking for is cardinality of A. But as you probably know, there is a sort of secret task in combinatorics where you actually have to prove something is finite before determining its cardinality. So it can go in one of two ways. You can know that A is finite, and that leads to A1 is finite, A2 is finite, all the way through to AN is finite. Or you can know that A1 is finite, A2 is finite, all the way through to AN is finite, and putting them together gives you that A is finite. So it can go either way, but no matter which direction you go, you know that A1, A2, all the way through to AN are all finite. So if you have that being the case, and A1, A2, all the way through to AN are pairwise disjoint, then you find that the cardinality of A is equal to cardinality of A1 plus the cardinality of A2 all the way through to the cardinality of AN. And that's what we call casework, because we're breaking the task of finding the cardinality of A into the task of finding the cardinality of A1, A2, all the way through to AN. And those are the cases. I'll give you an example, not a very difficult one. Let's say we've got 4 green balls, G1, G2, G3, and G4. And suppose we have 3 red balls, R1, R2, R3. And we want to know all the ways of pairing up a green ball with a red ball. So what we'll do is that we'll break it up into cases. Case 1 is where we have G1 being the green ball. And the 3 cases for that are that it gets paired up with R1, R2, and R3. Then we can consider the second case where we choose G2, and we have once again R1, R2, and R3. Then there's the third case where we choose G3 as our green ball, and the cases are R1, R2, R3. And finally, we have the case where the green ball is G4, and the cases are R1, R2, and R3. So when we put it all together, we find that there are 3 plus 3 plus 3 plus 3 equals to 12 possibilities. Or let's call them pairs. And that's the count. So we've used casework there. The second topic that I want to discuss is complementary counting. It is very much related to the addition principle or casework. And if addition corresponds to casework, then this corresponds, complementary counting corresponds to subtraction. What we have is that, say, U is a finite universal set, and A is a subset of U, which means A is also finite, then A intersection A complement is obviously empty, but A union A complement, so the complement of A in the universal set U, is equal to U. And by the addition principle or casework, that means that the cardinality of A plus the cardinality of A complement is equal to the cardinality of U. And that means we can determine the cardinality of A complement using subtraction. So the cardinality of U minus the cardinality of A. And that is what we call complementary counting. Because we just found the cardinality of the complement by subtracting the cardinality of the original set from U. And you can write this in another way as well. You can write it as the cardinality of A is equal to 2, the cardinality of U minus the cardinality of A complement. It depends on which one you're trying to figure out. And the last thing that I want to mention is it's called, or at least I call it, symmetric complementary counting. It combines the bijection principle with complementary counting. It looks like this. So let's say we've got a set and we have A and B here and C here. So we've broken up the set into A, B, and C, but A is equipotent with B, which means the cardinality of A is equal to the cardinality of B. So what you can do is that you can say that 2 times the cardinality of A, since it's A plus B, plus the cardinality of C is equal to the cardinality of the universal set. So this whole thing is a universal set. And that means that you can find the cardinality of A as doing the cardinality of U minus the cardinality of C divided by 2. And that also equals to the cardinality of B. So this is just a common trick that I wanted to show you because it does come up fairly frequently. Thanks for watching, and I'll see you next time.